This lesson we are going to learn how to read the state of a push button. When it is pressed, we read it on the serial monitor, and also we turn on an LED. And for the second project, we push, the LED is on, we see it here, and push off. This is called toggle. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. Let's have a look at the documentation. If you come here under this ESP32 starter kit from SunFounder, go to Arduino users and then 5.1. This is our lesson for today. And the component that we need is the ESP32 microcontroller. We can use also extension board, breadboard, jumper wire. We need resistor, LED, and we need push button. And then we are using some pins for the input and some pins for the output. Pins, we should not use them as an input because these are strapping pins that they are used when the device boots up. So we are not using them. And here we are using one LED with a resistor to turn it on and off. And then we use a push button with a resistor to read the push button. The wiring diagram is here, which I'm going to show you at the bottom of the page. And at the bottom, we have this code, which I'm going to modify and show you. And here are some explanation and how it works. The details are here. I will provide you the link so you can view this page directly. To understand the switch, this is our bulb, and we have a power supply or a battery. And this can be motor, this can be any other load. For simplicity, I'm just using a bulb which has two wires. It has been connected, one wire is connected to one terminal of the power supply, the other is to the other terminal, and it is connected, and as you can see, the light is on. But we need to have a switch in a way to turn this on and off, so we disconnect one of the wire, either positive or negative, but preferably it's always positive, so we cut it, and this is called a switch. Job of switch is to turn it on, which means connect this path of circuit. Right now it is off and nothing can flow and the light is off, and when you connect it, when you turn it on, the light is on. So this is our basic switch to turn on and off a load. Now there is another type of switch that can return back to the position like this. It's called push button, and so the push button job is that if you press it, it will complete the circuit and electrons move and the light or load is on, and once you remove your finger, it will return back. So this is our push button, but in order for this to work, you need to keep the button pressed continuously so the light or load is connected. Now, to understand it, in this lesson now, we have pin 14 connected via a 10 kilo ohm resistor to the ground. This could be 1 kilo ohm, 10, 25, 33, or up to 100 kilo, even maybe higher, but it's preferred around and less than 100 kilo and higher than 1 kilo ohm. So this is connected to the ground, and we have a low sensed by the device, by the input. So pin 14 is low when it is when the push button is not switched, so that it's connected to the ground. Once we push the button, then 3.3 volts come here, and we have high. High means in this case 3.3 volts, and low means 0 volt because it is connected to the ground. Now we have high, and we can read it. Once we remove our hand, it's automatically connected to the ground, and again low is always there. In this case, there is, when you connect it to high, when you push the button, there is some current which you can calculate it using Ohm's law. Current is I is equal V over R. So 3.3 divided by 10,000, it's very small or negligible amount. Plus also we are just pushing it for a small moment. It has no effect in many applications. Very few applications we might be concerned with the current. Now, if we don't have a resistor and the button is pushed, then we have high at this pin. That's fine, and it's working. The problem occurs when you release your finger, then there is no resistor, and this pin has no specific state. It's unknown. It can fluctuate, go high and low because of the noise or other charges around this pin. So that is creating unstable situation or unpredictable, because it might go up and down. For that reason, we must always have a resistor. If we want the pin to be low, always connect it to low. If you want it high, then we will switch this to, and we will switch the terminals. So the resistor will be in here connected to 3.3 volts, and a push button will be here. And when you don't push it, the resistor, it will be always high. When you push it, it will go low. As simple as that. For this lesson, we need an LED, we need a push button, we need 220 ohm resistor, and we need 10 kilo ohm, 1 kilo ohm, 20, even 100 kilo ohm will work. That's fine. And then we need 4 long wires, red, black, yellow, and blue. So we need 4 long wires. Then we need 2 short wires. Let me now explain the wiring. First, we have to look at this diagram. We have connected a resistor to pin 26 of our board, and the other side of resistor is connected to the anode of LED. The cathode, the side that has line or the shorter pin, is connected to the ground, which I'm going to show you. For the push button switch, one side is connected to 3.3 volts of power supply of our board, and the other side, which is connected to pin 14 of ESP32. From pin 14, we also connect a 10 kilo ohm resistor to the ground. Now, this is exactly the same wiring which I'm going to follow step by step. In order for this to be inserted properly on the breadboard, let's get a small plier and straighten the pins. This way it will get longer and will be inserted easily. Let's do the wiring. First, we get our LED. The longer pin is positive. Insert it somewhere here, like that. It has been inserted. And get the 220 ohm resistor. The 220 resistor has 2 red color on one side, so you know one side of the resistor should be connected to the anode, to the longer pin, and the other side doesn't matter where, just somewhere on the right side. And then we will connect this yellow wire to the side of the resistor, anywhere on the same line. So this is done. Now let's get this black wire and connect it to the left pin of the LED. So let's just check our LED wiring, see if it is correct. Connect the black to the ground, and then yellow to the 3.3 volts, the last pin here. and if the LED turns on, your wiring is correct. Otherwise, flip this if you made mistake. This should be this side, the longer pin. So the wiring is correct. Get your push button. The push button cannot be inserted incorrectly. There are two directions, so you can put it either this way or rotate it. Once it's on the right orientation, you can insert it easily. Then get a resistor, and we will connect to the left pin and connect it somewhere on the left. So from the left pin, just connect it, and I'm connecting it somewhere on the breadboard like that. And then let's connect our LED to this ground. We are making this blue as our ground. So let's connect this black wire to the blue anywhere, that's fine. And then get another short wire, and from the resistor connect it to the ground. So I call this ground now, this blue. And connect it somewhere on the blue, that's fine. Now we have 3 wires left. Let's get the black wire connected to the ground, and this will be connected to our ESP32 to the ground. Get this red, and it will be connected to the right side of the push button, and it goes to 3.3 volts in here. So get the red from the right side of push button and connect it to 3.3 volts here. The blue is connected from the left pin of push button, which is resistor is also connected. It goes to pin 14 here. This from the push button and from the resistor, it goes to 14. So I'm going from the push button and the resistor here, connected to pin 14. And here. Now this yellow is connected from the resistor to pin 26. So from the resistor we go to pin 26. This one goes to pin 26. 26 is just leave one empty spot between 14, and that is 26. Now let's go open the project. Click on File, Open. If you are not in the same location for any reason, click on Download. This is based on the instruction that we downloaded at the beginning of the course. Click on Download, ESP32 Starter Kit Main. Double click to open that folder. Double click on C and double click on Codes, and then find 5.1. 5.1 is called Button. Select and double click to open it, and then this is the file, and click Open. The code is opened. Let me now explain it. So first we define pin 14 for button pin of type integer, constant, so this cannot change. And then we define pin 26 for LED pin. This is also integer type, and it's constant, so this cannot change during the execution of the code. We have another variable called button state with 0 and then integer type. So this is holding when you press the push button. Inside the setup, we initialize the serial monitor with 115,200, and then using pin mode, we get the button pin, which was defined at the top, as an input. So this is reading our input push button, and this pin is LED pin. Using pin mode have been defined as output. So this is to control the LED. And this portion runs only once inside the loop, which runs from here at the beginning and then ends in here. We do the following. First, using digital read. Digital read is a function that you write digital and then read with capital R, and then you put your value of the pin. So this reads the pin either 0 or 1, and the value is stored in a variable called button state, which is defined at the top of the code. Then this is printing it on a serial monitor, either 0 or 1, and then we have 100 millisecond delay, so the screen is not cluttered with a lot of information. And then here we check if button state is equal. This 2 equal means we are comparing it if it is high. High is a constant variable within Arduino. So this is as if I type here 1, but let's have it as high. So if it is equal high, then we use digital write. Digital write is writing a value to the pen with high or low. So we write this value to the pen and the LED is turned on. Else means otherwise. If it is not high, which means if it has not been pressed, then we turn the LED off using digital write and the pen, and we set it to low, and the LED will be off if we do not push the push button. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board has been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here, now it's connected. If I disconnect this, one of them disappear. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. Now let's upload the code. Here, let's click on the serial monitor. Pay attention here. We have 115,200. We have to select the same baud rate, otherwise you will see something like this. So click and select 115,200, and you can see here we are getting 0, and it shows 0 because the push button has not been pressed. Now if I press this push button, we are reading 1 and the LED is on. Now this is our second project where we will do the toggle. Instead of push and on, we are doing the toggle, which means push on, push off. So now it's on, I'm pushing it, and releasing my hand, it goes off. And I'm pushing it, it's on, even releasing my hand, it's off. So we are changing the state of LED from on to off or from off to on. Let me explain it. This is called toggle. And this is the second project. I have updated it and changed it. This was exactly the same. This is the same. I have added these 2 variables. One is called LED on, so we will remember if the LED is on or off, and also we will remember if the button was pushed. So we need to use these 2. And then this is the same. Nothing has changed inside the setup. Up to here it's the same. And here I have changed this, and I say if button is pushed equal high, and these two ampersand means compare it, and it means and, so one condition, and then second condition, if LED is equal low, in that case we say the push value 1 minus push. This is called toggle. There is another trick, and we can get the push with the exclamation mark, which means push if it's high, make it not, or make it low. If it's low, make it high. So that's one trick. This is another trick. And we have 100 millisecond delay because when a person pushes the push button, we have to give them some time, otherwise it will vibrate. So this is done now, and here we now remember LED state, whatever is the button. If the button is high, so we will remember the LED is now changed, so the LED value will change, LED on. Now here, because this one will be used again in this line. Now the F has changed. Now we check if it is pushed, then we change it to high. If it's not pushed, because the push is remembered here, so we print this text LED on, and then we turn the LED on, exactly the same. Else we print continuously this LED off, and also set the pen to off, and that 100 millisecond is here, so this will print the text with a delay, otherwise the screen will be cluttered. And here is the demonstration. I've connected it using the provided lithium battery, so I don't have to connect it via USB. And here, push, release, on and off. This is called toggle. And 100 milliseconds is working here. If I do it very quick, you will see that it will not work. You see, I press it right 3 times, but you see, it didn't work. Quick, but 100 milliseconds is okay. Normal press, that's good.